Hi, everyone. So several of you are joining me today, and if you haven't yet so far, I'd encourage that you revisit the tally function, because it's actually what we're doing this week is more theoretical or conceptual than syntax-based. What we have actually in terms of content on the course website is that we've also added material relating to various probability functions. But I'm going to walk us through the code and some questions related to the tally function, and we're going to just explore that, revisit it in depth, and address some of the concepts that Ethan had discussed in class. So for those of you who are joining us on time, I was just talking with one of the students, Shri, and he was asking about the relative risk and the code related to that. And I think the main point we want to emphasize here is that, again, the whole concept is conceptual, and that we're really focusing on not just the code, but how to interpret or really understand the output that you're reading in the language of probability. And some of this can be counterintuitive. So before we begin, I would say I'm going to share my screen, and I'll just show you another time how to download the data sets, because I think that's always important to do. So I'll share let's see, if I can share the website. I'll share this screen. This is the intro homepage. This is our Canvas course homepage. You should see this. If anyone cannot, then please let me know. Let's see if I can get myself on the screen. No, I can't. This has been my perennial issue. That's fine. Okay. So the first step we have to take is that we're going to download our data frame. And the way that we do that is we're going to go to quizzes, and then we're going to go down, to our problem set number 3 right here. And we're going to click on that. And then we'll scroll down here. I'm just going to click right outside of this button, and I'm going to scroll down, and we click preview, or some variant of that if you've already started. And you'll see that we're taking on, today we're going to look at syntax and data as if you were a social epidemiologist. A social epidemiologist is essentially a statistician, an applied statistician who looks at the population prevalence of health in various countries and various samples. And this is an issue that's relevant when we talk about probability. It's an apt issue because when you think about risk factors or probability, it's a topic that's very common in epidemiology. If you go to the doctor will often give you probability information based on insights and the data analyzed by social epidemiologists. The data set we're going to analyze is another R data set. So as usual, data we're downloading is an R data frame. What I'm going to show in future R tutorials are some hacks or some techniques to download other kinds of data, because I know some of you are already asking, look, I have a cool data set and I want to download it, I want to analyze it, but it's not an R data set, and most typically aren't. The GSS in particular is short for General Social Survey. It's a repeated cross-sectional survey of the American population. In other words, that means that every year about 2,000 or 3,000 Americans are surveyed regarding their attitudes and beliefs. And we're analyzing data collected in the year 2012 where people were asked about their self-reported health, among other things. So let's just download the data set first, and you'll see that these tabulations here actually our manipulation and understanding of these data are actually based on these analyses. So let's scroll down, and this is where we get to part 2 of the quiz, and this is where you just click once. Actually, you'll see I already downloaded the data sets if you look down in my window, but I just click it once. You might have to double click it, and you should have problem set 3 R code, and that's a script file, as we know, and then we have an R data file. And I talk a lot about what I call data hygiene or workflow, which is in essence making sure that your analysis, if you do it once, you can do it again. And that's why I always encourage that when we talk about data analysis, we typically want to keep all of our scripts and our code in the same place. So what I encourage you to do is open a folder and create a directory on your desktop or in your documents folder somewhere accessible, and put the script for this code and the data frame in the same file folder. And that's what essentially I've done, and I'll show that when we go to our RStudio location. So let's go to the scripts. Let's open RStudio, and I'll share that screen now. We'll switch to RStudio. Are there any questions about downloading the data frame before we get to the actual code? And I'll walk you through some of the concepts this week using the code. Feel free to chime in if you have any questions.
No.
Could you give your name? I'm sorry, I don't know if I can see everyone here. Is there a question? No? No questions. Okay. Now you should see on your open screen, you should see RStudio. And you see the familiar panes. As I said, you should mute your screen, I would have to say, just because we may hear some background noise. You'll see that I already have my workspace saved because I've opened up my environment before. You'll have some path file. This is the text that leads you to where your folder is. And what I have actually on my desktop is I have my R code open, and then what I added to my code is actually, oh, I don't actually have this, do I? No, I don't have this in the syntax. Okay, we will do this. So, oh yes I do, I'm sorry. What I want to show to you is that after downloading your code, I want you to type in this little bit of syntax, which is, I'm going to actually break it out into the language of R syntax, because you should run your scripts, highlight your script all the way up from line 1 through line 12, and that should install, and click run, and we should install our package in our library, and you'll see that it's downloading again, and that we're going to install the library as usual. But once you've saved your R script and your R data frame within the same working folder, we're going to do what we've done before, which is here I've expressed the working directory as a nested set of functions. But I want us to add after line 12, and this is not in the problem set code, so it's not in this code here. I want us to use two important functions, and this is the set working directory, and this is the get working directory. What the get working directory does is that it tells us what our working directory is. A working directory is simply, it tells the computer which folder you have open in your analysis, because we're doing an analysis somewhere on your computer. So you'll see that after I've run the syntax through line 12, I just typed in get working directory, and it's a base function, it's a standard function. You'll see that, oh look, that's a function, that's my location. This is where I am in my desktop. I'm sorry, this is where I am in terms of my analysis. Now, if we set our working directory, we could do that as well, but I also, let's do that. So set working directory says there's an error here, and that's because I have to tell my computer where to set the working directory. So you could either define your working directory as an object using this assignment operator. We say, this is what our current working directory is. And there it is, that's the working directory. And then we say, okay, we're going to set it to that location. Now I believe I actually have a / desktop here. I'm not sure if this is the working directory I want to work in. And we can test this if we load the data frame.
Sorry to interrupt, Nate.
So we have I'm sorry, hold on for a second if you don't mind. So what we actually have is an issue here, which is that I know where my folder is, which is that I should actually be setting my working directory on my desktop. So if you know where the location of your analysis is, you can highlight your path file, put it in quotes, and then this will define your working directory. Here, we'll just do this in fact. Sometimes get working directory will only work if it's actually the directory where you want to set things. The easier way perhaps is just to type in set working directory and then type in, prob set3. And this is actually my folder that I've defined on my desktop. So this is actually the easiest way is just to say, here's my path file. This is my location on my desktop where I have both my R script and my data file. And then we can check this if we use the directory function. And this just lists in the files, prints in the console screen rather, prints here, our contents in this working directory. So now that we've set our new working directory, and I'm going to remove the old one, because the other old one was actually not correct. Now we're going to list the contents in our console. And what should we have? We should have our script and we should have our data file. We will also have, if we're saving this correctly, we should also have a history file. But that's not as important. Yes, we have our most important files. We have the R data file and we have the R script. So what I encourage you to think about is keeping everything in the same location. So I want to underscore that these three commands right here are actually not in this R code available to you on the course website, but that they're crucial when we think about data hygiene. So you want to save your contents to the same working folder. So you might have some other path file. All this text here, this green text is in computer programming languages called a path file. If you're using a Mac, you'll have slashes that go the other way.
Right.
I'm using a PC. And I would create a new folder on your desktop that's called problem set 3 or something similar. And in that folder, you should have two contents. So this set working directory, this says that this defines or sets location of all analyses. Now the directory function prints in console the contents of our working directory. And then from here, our analysis becomes easy because we have everything in the same location. And now we can load our data. And you can use that load command, load our data frame using load function. So these are three new commands that we've visited before, but that I'm elaborating a bit here right now because this is the same, this first part of analysis is the same procedure. And when you think about doing your own analyses, I encourage you to think in terms of directories and defining your workspace in one location. That way, if you revisit a problem set or an analysis, after a couple days, let's say you do an analysis on a Friday and you revisit it on a Monday, you know where you are, you can revisit your syntax and you're like, okay, this is what I did last Saturday. Sometimes I'll include annotations as well. So I just want to underscore this is added syntax right here. And then of course, I can highlight this and I'm going to hit the tab button just to put that syntax in a little bit, so that's different. So are there any questions? Whoops, sorry, I didn't mean to do that. Are there any questions about the actual, I don't want to install those. I accidentally hit a button for R Markdown. Are there any questions about setting working directories and then printing that and then uploading the data? I think those are crucial components of analysis.
Not a question, maybe perhaps a request, if you can just copy paste it in the chat so we can copy paste it and use it as a template for our future, because we cannot do from the screen.
Thank you. That's Alina, right?
Yes.
Yes,
hey.
thank you. I recognize your voice. Feel free, when you ask questions, feel free to chime in. And also, if you don't mind, just introduce yourselves to the other participants. I'll put that in the chat. Thank you, Alina. That's actually a good bit of information. Let's see, how do I don't even see the chat anymore. Let's see. Well, sorry, I'm highlighting somebody. I'll be sure to share that to all of you. Let's see if I can. I'll continue with the the section, but can anyone chat me? Because I'm having difficulty actually.
Sure, I'll chat you.
Thank you. I don't know where that is on my screen exactly.
Change your working directory, correct?
What's that?
Can you change your working directory?
Yes, and that is, so here, I'll just include the syntax that's necessary. Now, the point here is this information right here. So this is, set working directory is a function that changes your working directory. So if I did set working directory and then I specified any location on computer, you typically have to include that in quotes. That's how you change your working directory. And all that means is you're just telling the computer program, I want to move out my analysis and tell it to work here. And this is where I'm defining the parameters of my analysis. That's the set working directory function. Does that help answer your question?
Yes, it does. Thank you.
Okay. That's something different than get working directory. Now, I used get working directory before, and typically in previous sections I've automated that. I've sort of given you this syntax without really explaining it, simply because we had so much content to cover, because we have less content to cover this week. So another command, if you want to, or function if you want to look at this, is the get working directory. It just tells you where you are presently. When I started, I had assumed we were at the right location because I did some analysis before the section started. But if you recall, and we can go to our history, when we started out, I used the get working. Oh, this is not the right history. If I used get working directory before, it actually printed out everything up until my desktop. So I had to add some information here. So the get working directory is helpful if you want to know where you are. It tells you where you are, where you're presently working, because you're always working somewhere. And then this defines or sets your working directory. So I encourage you to look at set working directory and then get working directory. But get working directory and then the directory function, both of those are two functions that I use every day, because I'm always wondering, where's my analysis? What am I looking at? What are the contents of the present file that I'm looking at? So I'll put that, actually I'll put that third command here. I'll copy and paste this in. I'm hearing some background noise. If you could, I just encourage you to mute yourself, just to ensure that you won't be heard. Okay, so let me add to the chat room. I'll chat to everyone. I'm going to chat to all of you. Again, the syntax, and this adds to what I had told you before, this get working directory function. This is necessary information. So this will tell you where you are. On a Mac, these slashes will be that different. It'll look different. You'll probably just have the user's sign, right? Something like that. And then the directory, it'll tell you what's inside your working directory. And this is exactly what we want in our working directory. We want two things. We want our data file and we want our code. And then we have this load function. And then we're going to load the data frame right now. Any other questions about directories, getting or defining directories, establishing them? How do you find what the path is on a Mac? You should be able to use the get working directory function. So if you go to your R console, you should type in get working directory, and this should tell you, it should print it out. So that it'll tell you where you are. Another thing to do is once you've defined your folders, you can navigate within your computer to your folder, and then define, navigate in that way, if that makes sense. Right, so I can use get working directory to define, to my, set the location to my desktop, where I might have other folders. Any other questions about, does that answer your question, by the way? Are there any other questions about setting directories or establishing them? Okay. All right. So what I want you to do is I just want you to feel comfortable getting to this point, getting to what is now line 25. Now, of course, it actually won't be line 25 when you have the syntax. It will be, something around line 15. We changed the syntax a little bit, and that's okay. But feel free to ask any other questions, because this is part of data. I call it data hygiene. I call it workflow. It's simply the way that you define and start your analysis. And we always want to start our analysis so that we can tell the computer where we are, know what's in it, and navigate our computer and navigate our analysis within our computer. And then we can load our data set. And then here we have a very familiar location, or very familiar screenshot, which is we have our data frame, we have our plots pane, we have our syntax pane, we have our workflow. Now we can basically do what we want, and really get to the concepts into the analysis. So we had talked about the fact that there are other ways to explore rows with our data frame. Here I introduce in the analysis a few functions that actually, in addition to this view function, we can actually figure out, and this will tell us what's in the data frame. So here we have a categorical variable, sex or gender. This is the respondent's self-reported gender. We have their poverty status. We have their class, their social class. We have their health. And this is self-reported health, and it's a very common metric. I actually have a couple of papers that I published looking at self-reported health, because it's actually a very good measure. It's a robust measure of mortality and morbidity. So it's a very common measure to ask someone how healthy they are. And we know through social epidemiology, through statistics, that if someone tells you that they're in fair health, it actually is a good probabilistic measure or proxy for actual physical conditions. It predicts mortality. It predicts earlier mortality, and it predicts earlier morbidity or onset of disease. Now in this data set, we have other measures of health. We have happiness, we have depression, and then we have, and if you look at, actually, if you linger over this is a nice thing about the view function. You can see that this is, we can see a couple things about our variables. First of all, that it's the 7th column. Second, we can see that it's a categorical or factor variable, and we can see that it has 2 levels, which is really neat. Right, so here is whether or not the participant agrees or disagrees that they're in poor health. And then here we have a yes/no variable defining change in health. So there are other ways to explore this data set that I want to show you, which is this number of columns command. So here we're taking the data set or data frame, and we're saying we want to know how many rows it has. And that number of columns and number of rows. And in some ways that's a little redundant, you might say, because look, we can actually look in our data pane, and we actually already know that because we have 560 observations of 8 variables. Nevertheless, these are other functions that you should be familiar with. Quite often when we deal with more messy data, when we say do the final analysis, we may not know the actual dimensions of the data sets. Another function that I've used before, I don't know if it was introduced earlier, but I use it all the time. It's called the dimension function, and this gives us both the number of rows and columns in one screen, and we can see that right there. It prints the rows and the columns. And we should always think about data frames or matrices in terms of rows and columns, because when we deal with more advanced code or syntax, we're often specifying first the row and then the column. It's just a sort of a linguistic convention using RStudio that I want you to be aware of. I feel like these are pretty basic. Any questions about that part of the analysis? Otherwise, we'll proceed. All right, great. So when we explore the data in this section, we're using the tally function again. And I think it's important to just explore this in greater detail. Here we have the tally function that talks about self-reported health, and I underscore and I present this in discussion, that this is, and I described this in our tutorial as well, that when we use the tally function, I'm going to just give us a little bit of space here, that tally is one thing, but what the people who have written the Mosaic package have done, which is quite clever, is they've expressed almost every single argument or every single type of analysis in this similar way. So even though last week we did numerical data analysis, we still had the same sort of organization of a command or a function. And I want to show us this, that if you click on it, if you highlight this bracket right here, or you even put your cursor right in front of the open parenthesis of the tally function, you'll see that the other end of this is highlighted. This simply means that the tally function is whatever we include in here, and that is all of this. This function includes arguments that are separated by commas. I'm going to put a little space after each one, after each little segment of each argument, just to underscore, to show and reveal to you that yes, here we have bits and pieces of an argument that are each relevant. In fact, we can also do this with an R. I've often shown to you that you can type a pound sign and it'll turn green. And this, everything after a pound sign, this is a comment. What I want to also show to you is that you can do this after a bit of code. I can type in the pound sign. This is an argument. My M button is sticking. There we go. My M key was sticking on my keyboard. And then so what I want to show this to you is we're parsing this like we would parse a sentence. So this is argument 1. And this is argument 2. This is argument 3. This is argument 4. And this defines the end of the function. Close bracket. Close parenthesis, sorry. And this defines the start defines the start of a function. Open parenthesis. And that's almost always the case when you have a function. When we do the view function, there's almost always a open and close parenthesis. It'll typically want us to define that. If I put the cursor after the end of the bracket or define it on different columns, you'll see that it wants me to put something here. It'll highlight the open and close parenthesis when I type any kind of function, because RStudio is informing me and reminding me that yes, this is basically like the end and beginning of a sentence. And that when you anytime you open a parenthesis, it'll complain. In fact, it'll autocomplete. So we'll do the view function, and then I'll purposely. Oh, look, there's a close bracket already down there. Let's see what happens if we run in a function without. It already complains, and it actually gives me 2 complaints because it's getting a little confused about where the close function is. It sort of goes to the next close parenthesis and thinks that all this stuff here is a function. So the syntax is looking for something, and it says, look, unmatched opening bracket. So I don't like this. This is sometimes where R gets a little idiosyncratic, because bracket is not technically true here. This is why if you heard me vacillate between the word bracket and the word parenthesis, is that a bracket is actually technically the key that's on a PC. It's quite different, and it actually means something quite different. But we'll often sometimes use bracket and parenthesis interchangeably. But the main point is that your syntax will complain and it will not run if you don't have both closed parentheses. So think about that as the core of a function. And what I want to emphasize here is that every single argument that we have, or every single function that we have, typically is an equation. because we're basically using, and that's what this tally, this little tilde here is. And the tilde is just this little keystroke. You type shift, and I use the button right below my escape key on a PC, and there's the tilde. So this is a tilde. And what is a tilde? Basically everything to the before a tilde is what you're going to define as the outcome. In this case, what does that really mean? It means that anything that you produce is a consequence of everything after the tilde. In other words, what we're really saying is produce a tally that is a consequence of. And we could actually define this as an object if we really wanted to. We could say object, outcome. But we don't really want to do that because we just want to print in our console. We're going to print in our view console here. By the way, if you noticed, there's something a little strange with my console because I erroneously typed the view function with only an open parenthesis. It now has a little plus sign. What that means, instead of the little caret here, this is sort of your starting point. If you see that, it means that the computer thinks that there's still something, it's waiting for you to finish that function. And that underscores how important the open and closed parentheses are. So you should always have matched parentheses. I'm just going to end that. And then it'll say it's invalid because, of course, I didn't define the object here. Now, if we just type, I want to just make that mistake one more time and see it auto completes that to the extent that it doesn't even like it. If you find yourself with a series of plus signs like this, because the computer thinks that you have a problem, type the escape key, and it takes you right back to this starting point. So if you ever find yourself in that kind of in a place where maybe you have a bit of code that you run partially and you're wondering why you have these little plus signs, the computer is saying, okay, we started an argument or a function, where is this taking us? Now, let's go back to the logic of the tally function. What we have here is the first argument we make is we're going to define our variables. And we're saying as a function, or sorry, I'm going to try not to use the word function, but we're going to say, because it actually is, that quite literally, the Mosaic developers use this tilde language to express the first argument as an equation. And what we're saying is the output that we produce on the screen is a tally of health and poverty. And in other words, the first argument you have before the comma is an argument expression of the variables. And these must be verbatim variable names, so keep in mind variables. That capitalization is important, so this is case sensitive. Argument 2, as we've defined before, right? This expression of the table of the probabilities, we could say, right? If you recall, we can have them as counts, we can have proportion, we can have percentages. Those are the three main types that we want to focus on. And typically, I see that this wasn't written in the syntax, but typically I like to put spaces between my operators. These little things are called operators. Here's an equal sign. Just because it's easier to read. This is, if you go to Google, if you ever work for Google, they actually even have a file, and I'll talk about this in our tutorial if I have time. They talk about writing conventions. They typically say, this is the way you should write syntax so it's readable. Well, because it's easy to make mistakes, and if you make one tiny mistake, you can actually throw everything off. So Google typically recommends in their templates for R coding to have spaces between operators. It's just easier to read. It might take up more space. It's an extra button to push. I don't think it's typical to have spaces. I don't typically put spaces after after each variable, but you'll see that this what doesn't really matter. Argument 3 defines the data set we're using, right? So this tells our which data set to use. And then argument 4 tells us whether to set marginal probabilities. And this could be true or false. You'll see that this is true. This true definition is, and you'll well, you'll notice a couple things. You'll see that, first of all, there's no comma here because it's the last argument. You just have to close parenthesis. Second of all, you'll see that this little true, this word true is all caps. You'll see that it's in the color blue. And that's because it's a different kind of argument. It's essentially, it's not in the data. It's not a data set. It's not a variable. It's actually a built-in argument. And you can actually even type this in shorthand. It's still in the color blue. You can just use the shorthand true, or T, capital T, or you can just actually say, write it all out. And this takes on one of two values. It can be set true to true or to false. So if we do this, then we'll actually get a tally where here it is with margins false, and then here it is as the other value, setting it to true, the margins to true. Well, what's the difference here? Well, here we have the total here that we've set. And that's really the only difference. One thing I want to see is, typically I don't write this, is this. Yeah, so if you notice, you'll see this is one thing we like. One reason we like RStudio is, if you notice my last argument, I erroneously put a comma here, which you shouldn't have, and it'll already complain. Missing argument to call, the argument to function call. That's just a bunch of jargon that says RStudio is complaining because it's saying, is there another argument that you want to include here because you have a comma? And if we actually had another argument we want to include, I could just type some mumbo jumbo, then that argument, see, that complaint goes away. Now, of course, this will not run, but the main point is you want a comma to separate every argument except for the last one. So this is, ours pretty helpful in terms of helping us out in a lot of ways. And same with the Mosaic package and people. So here we have, the relevant, the marginal probabilities for each outcome. Are there any questions about this syntax or this coding thus far? I haven't gotten into, say, some of the concepts like relative probability, relative risk or things like that. No questions? Okay. Then let's quickly go through the rest of the syntax then. So if we look at the first question here, it'll say, with overall health with 2 levels, fair and good, and the health and the poverty measures, what is the probability of being poor and in fair health? What is the probability of poor, non-poor and having fair health? We'll see that this is the format of the tally function that we want to express it as. If we ever think about a condition, and that's what the main difference, I'm sort of talking over myself. What I want to emphasize is that if we talk about a probability of 2 outcomes or joint probability, then we want to look at the probability as we want to use the plus operator. So for example, this question, the wording here is as overall health, and then it also asks the probability of being poor and in fair health. So as relative types of probabilities, you want to look at these subgroups right here, because you'll see that the plus operator says what is the probability of poor, given, and good. It'll ask for these joint probabilities. Whereas this pipe here, or this vertical bar, is a different way of expressing health, given that we know the level of poverty. And that's a big difference between these 2 arguments, actually. You'll see, or 2 functions. You'll see that these 2 functions only differ in terms of this little operator here. So let's go up to our worked example here, and we'll see that we'll do the same thing. We'll just change this little argument. We're saying we're going to tally health, given poverty. You'll see that what we've done here is that, and this is what I described in the categorical week, we're examining the probability of health given that you're in the non-poor category. And this means that the proportion adds to 1 in the columns. If we reverse that, we're asking a different question. In other words, if we reverse the order of the variables, and we put the vertical bar here, we're saying, given your knowledge of your health, what is your probability of being in poverty? And look at this. This will be a little bit different. These are different proportions because they're asking different questions. So here we see health as the columns rather than poverty as the columns. So the first variable defines the columns, and then this other variable defines the rows. So actually, and if you think about it, that's kind of interesting because it's quite comparable to how I was expressing the dimensions function in terms, this is why we should always think about matrices in terms of rows and columns, rows and columns. Well, that's what we're doing here. We're saying rows given the columns. So, and that's what we're kind of doing here. We're actually creating a miniature data set, actually. We're creating a data set with four, well, in this case, six little spaces. This is a matrix. And we're saying, what is the probability of being non-poor given that you're in fair health? What is the probability of, given that you're in good health, what is the probability that you're not poor? So the key distinction I just want to emphasize is that margins can be set to true or to false, and that will give us the marginal probability, so of the outcomes that we define. And key point number 2 is that we can set this to define joint probability, or we can define it as conditional probability. And key issue number 3 is that the ordering of the variables defines what it is that we're trying to ask our computer to do. So as a question is asked, it actually wants us to define, set our margins to true, right? We can just use the capital letter T, and ask about health given poverty. And that's what we have there. So here we are just breaking down that tally function in ways that express it in terms of marginal probabilities and whether or not we want to use that pipe there. And I think the rest of the syntax is relatively intuitive. Yeah, I'm sorry, I forgot about this. The change variable, I knew I made a mistake here. When I was describing the data, this is whether or not people are satisfied with the current healthcare system. So I have to say one issue that we always have with R is that there isn't typically a way to add variable labels. If you're used to using other kinds of data structures like an SPSS file or a Stata file or a SAS file, they often have labels or additional information you can append to these variables. So typically within R, you can't do that. One way we do that, one easy way to handle that issue is you look at the code book. And I've spoken to several of you, especially the graduate students who are doing your own project, about how to examine code books and things like that. And we'll talk about that in future classes. But any other questions about this? Because I want to take us to, I think, an important point about relative probabilities.
Yes, I have a question.
Yes.
I'm getting a bit confused in the way of expressing the question.
Yes.
In the problem set was something quite similar. What's the joint probability? In that case was about being depressed and being poor. We can take, for example, here of having a good health and being poor. If it's saying joint probability, it's the same as saying what's the probability of having a good health given that someone is poor. Like the word joint probability, it means like it's a synonym of saying given something. I don't know if I'm being clear with my question.
Yeah, is this Matthias? Is that right?
Yes.
Yeah. Could you try to repeat your question? I'm not exactly sure what you're asking, but I do.
Yes.
The general point I agree is that language here is crucial, and it can be somewhat confusing. What I wanted to express today is that if we think about the functions and the language of functions as a type of language that is relatively standardized, you should be very familiar with this. That's a crucial distinction, but I don't want anyone to get tripped up by the language, at least in the questions that are asked, because the details are relatively important when we talk about probability. So could you try to repeat the question, and I'll do my best to answer. And if not,
Yeah, sure.
I'll answer after class.
Yes. In the problem set of this week, the question number 12 is saying, what's the joint probability of being depressed and being poor?
Yes.
So having the word joint probability, I want to know if what's the joint probability of being depressed and being poor means the same of saying what's the probability of being depressed given that a person is poor.
Oh, I see what you're saying. Well, what's your intuition?
I think it is because of joint probability I was looking. I think it means the same.
Okay, so in a way, yes, right? I would have to say yes because the main point, so the conceptual distinction is between joint and what's the other type of probability that we discussed in lecture. I'll give you the answer. It's disjoint. So these are, joint are defined as mutually inclusive. In other words, if they can both happen at once, and disjoint is, or mutually exclusive, and this means if they can't happen at once. So the question really to ask is what, I think in terms of syntax, is what function would you use, Matthias, in terms of, I don't want to put you on the spot if you wanted to decline answering this question, but how would you write the tally function to answer that question, to ask about the joint?
I would use exactly the same one that you have on your screen in the line 46 and using the same as 47 one. I think it means this, but I want to confirm like in the 62 one. Like it's not the same as saying plus, it's saying one giving the other.
Right. So in that sense, yes, right. So this is where it gets a little confusing. Actually, if you look at joint probability, you want to know the probability of the co-occurrence. In other words, you want to look at the probability of both events occurring. So actually, if you want to look at the probability of health, if you want to look at the joint probability, then you want to ask, what is the probability of being in both categories at the same time?
Okay.
So you actually want to use this plus operator because look at this. And I'll show you what the difference is here. So it's only 11. I'm going to use the round function, and this may be a little familiar to you. If not, that's okay. I'm just doing this just to make sure that we can be on the same page. I'm going to show you again this difference when we have the plus and the vertical bar. This is actually, sorry, that was my fault. I'm going to round this to 2 digits. So here we have a probability of 12% of being non-poor and in fair health. In other words, what is the probability of belonging to both categories? Are these mutually inclusive or mutually exclusive? Well, you can be included in both. So what is the probability of both categories occurring at once? You want to use this plus operator.
Okay.
What the like says, it's about a conditional probability. It says, given the probability of, given this category, what is the probability of being in fair or good health? So the vertical bar, in an intuitive way, the vertical bar tells us that the column, or setting the columns to 1, and defines probability in terms of, or conditions probability based on the first category we define, poverty level. The plus sign gives us the joint probability and tells us, and you can actually see that, we can see this because we only have one value equal to 1. And this says that this is because we have, this tells us out of the entire sample, we have 12% who are non-poor, 62% are in non-poor and good health, 12% are fair and good non-poor, 62 are good and non-poor, 8% are fair and non-poor, 19% are good and non-poor. Well, those actually add up to 1, so we can actually see this quite easily if we just type these values in. And you don't, I could just type this. You can also use more formally the print function. Well, I'm sorry, I didn't do that correctly because I forgot to put my decimal place here. So it's just right about 1, right? This is where rounding will get us a little bit above, out of the bounds of truth. But you'll see that this is what we're saying is that these are actually joint because they're mutually inclusive. When we're saying given another value, what we're saying is that we're describing conditional probabilities.
Okay. The only thing I'm still a bit confused is like some questions in the problem set as well were not using the joint probability word, so probably it's not changing in a way. So, for example, there is what's the probability of being poor and depressed? So that's a joint probability as well, even if it's not naming it, no?
And what was that last question? You sort of mumbled the last bit.
What's the probability of being poor and depressed?
Right. So
this is the same of saying what's the probability what is the joint probability of being poor?
So the key difference here is just if we think of proportions as probabilities, right? So that's key point number 1. Now probabilities, key point 1, and here we're dealing with proportions, right? And key point number 2 is that proportions are conditional using the vertical bar operator. And key point number 3 is proportions are unconditional using that plus operator. So that's all the major difference that we're doing here. What we're saying here is that you got to ask yourself, if we're saying given something else, then we're actually conditioning our probability. You should think to yourself, if there's any language that talks about conditional probabilities, if you're going to condition your probability on anything, then we're going to use that vertical bar operator. If we're not conditioning on anything, then we're looking at unconditional probabilities and we're going to use the plus operator. Conditional and unconditional. And if you look at even the syntax, you'll see that always we're setting the margins to be true, simply because that gives us the additional information about the probabilities themselves. Does that clarify your question?
Yes.
Okay, so if we're saying given something else, we're typically talking about a conditional probability. If we're saying the probability of both categories, we're talking about unconditional operators. And so,
sorry, excuse me, can I just have a quick follow-up question? It's Alina. I apologize. Along those lines, I do understand the difference where giving and there is a formula that we can, two parts of formula we can apply. I do, however, following up on Matthias' question about the problem set. The question 9 and question 12, they're exactly, one of them is asking what is the probability of this and that, and the question 12 is what are the joint probability. So the question, is there a possibility you can just look at the data set, because it's very kind of easy just to look at the initial, the data set we generated and see what is the probability of being in fair health and poor. So, isn't it like right there, 0.08?
So if you look at what is the probability of being poor and in fair health, is that what you're asking? You want to?
Yeah.
So this question. That's what you're asking about?
Yes.
As opposed to what? What is it being in the probability of?
As opposed to what is the joint probability of being poor and having fair health?
I see. So you're saying what if we're going to distinguish between two things? You're saying, well, the main point is these numbers here within this table. If we could sort of, I wish I could draw here. I think I could annotate. So if I could draw on the screen, yes, I can. Good. Okay. Yay. Can you guys see this?
Yes, those are the joint probabilities.
Okay, so these right here. I'm glad I can draw on the screen. I know that looks terrible. It should be a box. Everything. Actually, can I undo this now? Because actually I didn't draw. I was so excited I could draw. Let's just clear the screen. Clear all drawing. Okay. So what I want to show to you is that this right here, this is the joint probability right here.
Right.
These numbers right here. I just want to make sure. I'm going to scroll up. I'm going to stop annotating. I'm going to scroll up and I'm going to make sure I did the right argument though. Did we do the, yeah, we did the plus sign. Exactly. So the point here is that these numbers right here, these are the joint probabilities. So the numbers inside the table are called joint probabilities because they refer to two events occurring at the same time. So this is the joint probability of being poor and fair. This is the joint probability of this. Now, now the four joint probabilities, if we look at all these four, together within this little red, circle, we could say, they're associated with four mutually exclusive and collectively exhaustive events. So the sum of these equal, what value do these four probabilities?
1.
1, right, exactly. That's the probability, because that's the way we think about probability. So if you're asking about being the probability of level X1 and level X2, you're going to probably look at one of these cells. So what is the probability of being poor and having fair health? Here we have that. What's the probability of being non-poor and fair health? We look at that cell. Does that help to answer your question?
Yes, it kind of does. It's just funny in a problem set they're asking us, what is the probability of being poor and depressed? And then you round your number to the decimal. And then what is the joint probability of being depressed and being poor? Isn't it exactly the same thing? I might be confused. Like
Right.
It's two questions, but they sound the same to me.
Yes, right. I see what you're saying here. So the thing is, when events are independent, it's easy to find joint probabilities. But for unconditional probabilities, remember what we talked about in lecture. So if they're independent, it makes sense to look at them, but typically that's not the case for joint probabilities if they're not independent. For question 4, are there any other questions that you guys have?
No, I'm good. Thank you.
Okay, thank you so much for your help, really, for clarifying that question. All right, thanks a lot, and I'll see you next week. Bye-bye.
Bye.
Bye, guys.
Thank you. Bye.
Bye.
Bye.